In this video, we are going to have a research framework for fuzzy algebraic structures. So you'll have to choose your algebraic structure and then the fuzzy sets. We have a list for this and we have a list for this also. And the standard results that what you have in the algebraic structure that you must have. Then apply the definition over them. You'll have the few new definitions, examples, and theorems. So this is a broad out sketch of this research framework. For example, if we consider, say, fuzzy groups, then first we will see what is meant by a relation. See, we are not going to have the definition of fuzzy sets, intuitionistic fuzzy sets, and etc., but just an outline. So if we consider this relation, a fuzzy relation R on a set X is a function from X cross X to the closed interval 0, 1. A fuzzy relation is called a fuzzy equivalence relation if it satisfies these conditions. So R of Xx should be 1 and R of Xy should be same as R of Yx for all Xy in X, here for all X in X, and R of Xz should be greater than or equal to min of, that is minimum of R of Xy. These are all values. So you must have that to be, this one to be greater than or equal to minimum of these two. And we'll be using the word operations. So fuzzy complements, fuzzy union, fuzzy intersection, and then properties and examples and combination of operations. So these are as for operations that we are going to have in one of the columns. So here just a frame is given. Congruence relation, for which relation must be known. So depending on the operation that you know that the congruence relation is given, so it should satisfy this condition. And then special substructures, like once you have subgroup, this is the condition for subgroup and this is for the normal subgroup. And algebraic properties of once you have new and new to be fuzzy sets, then operations on them we know. And for this fuzzy groups, you need to check fuzzy subgroups or fuzzy normal subgroups. For them, you can check all these algebraic properties. And homomorphism theorems, like the homomorphic image and the inverse homomorphic image of a fuzzy subgroup or normal subgroup, or again fuzzy subgroups and normal subgroups. In the case of rings means you will be talking about here ideals, and here two conditions will come. And algebraic properties, again intersection of fuzzy ideals, um, uh, then fuzzy subrings if you are defining then for them. So all those will come under this category. And the thesis will be rich once you have the characterization theorem or a structure theorem, and then when you have the characterization in terms of level sets. So when you find any research thesis from the Shodh Ganga, you can see all of them, whether you are on fuzzy or intuitionistic fuzzy or spherical fuzzy or whatever it is, definitely they will cover all this. And then more than that, they can have, because even in fuzzy sets, you have lot of varieties. Even if you choose one particular fuzzy set, it may be intuitionistic. So even there you have some special fuzzy intuitionistic sets, and with them that you will be checking for that particular algebraic structure, what are the conditions, whether they are satisfied. If they are not satisfied, then why it is not satisfied? Can we impose any condition so that it becomes all right? So all that can be discussed in the research. So as such, very few only we have mentioned, just to know that this is the framework, because you may be wondering that from where that you have to start your work. So for that, just a hint is given on this video. So in the same way, for fuzzy rings Again, you can have all this can be discussed for fuzzy rings, fuzzy semigroups, again fuzzy semirings, fuzzy vector spaces, fuzzy near rings, and then fuzzy BCK or BCI algebras, fuzzy ternary semigroup, fuzzy ternary semiring, or fuzzy right ternary near ring. So there are lot structures, algebraic structures, and then you have to impose the conditions on them and check all the properties. These are some of the topics that we usually come across, whether you are in rings or semigroups or semi-rings, ternary, or whatever it is. You have the standard format. So you must understand what is going on there, and whether all of them are discussed. If so, that is how you find the research gap, and then you can work on it. So these are some of the algebraic structures that are known to you: group strings, semigroup, semirings, vector spaces, ternary structures like ternary semigroup, semiring, and near rings, and here lattices, then BCK-BCI algebras, right ternary near rings, and so on. So this you're going to attach with your in join, or I mean in BQ. Some may pronounce it as in BQ, or in RQ, in join Q, and so on. So fuzzy algebraic structure. So this structure can be any one of them, and you have lot of properties to be checked. So that is how thesis arise. Okay, so then L fuzzy algebraic structures, this again the same thing. In this algebraic structure, whether you are going to have this or whatever it is, that must be put here, and you can work on it. And many of them are over. You can find a lot of research papers, or even in Shodh Ganga, the reservoir of thesis. There also you can find the topics on fuzzy groups, fuzzy rings, and so on, or intuitionistic fuzzy rings, fuzzy semi-rings, fuzzy ternary structures, something like that. So you'll have to have a review on of all of them, or rather survey, and then whatever is not done so far, you can take it. That is your research gap, and you can proceed on with that. So interval valued fuzzy algebraic structures, intuitionistic fuzzy, and then bipolar fuzzy, Pythagorean fuzzy, and fuzzy soft algebraic structures, hesitant fuzzy algebraic structures, spherical fuzzy algebraic structures, linear Diophantine fuzzy algebraic, and picture fuzzy, M-polar fuzzy algebraic, MN fuzzy, and Fermatian fuzzy algebraic structures. This one is very latest. These are all latest topics. So whether all of them are covered or not, we do not know. So you'll have to search for the research gap and proceed. And even hyperstructures, hypergroups, hyperrings, hyper semigroups, they can be dealt separately, and attach fuzzy with that, like in RQ, fuzzy hyper groups, L fuzzy hyper rings, interval valued fuzzy hyper semigroups, something like that. So you have lot of openings, so you can do them. And similarly in the case of nitrosophic, not all of them have come as research articles, so you can explore that so far what has been done, and what is to be done. Now our generalization of fuzzy sets already we have mentioned, but once again, classical fuzzy sets, you have the value lying between 0 and 1, closed interval 0, 1, that fuzzy membership value lying between 0 and 1. Then intuitionistic fuzzy, membership, non-membership, Pythagorean fuzzy sets, you have the mu and v satisfying this condition, and picture fuzzy sets with this condition you have, and Q rung ortho pair fuzzy sets satisfying this condition, and spherical fuzzy sets satisfying this. So you must explore them. What this mu pi stand for, mu q. What do they stand for? All of them are to be the basic work should be done first, and then how to proceed. What is the framework? Only for that we have this video. Then T-Spherical fuzzy sets with this condition, Mn fuzzy sets with this condition, and linear Diophantine with this condition, M polar fuzzy sets with this condition. So with all this, you can proceed, and now that you can understand what is this simple framework for your research in algebraic fuzzy algebraic structures mean. So you need to choose your algebraic structure. We have got a list, and again you must choose your fuzzy set, which one that you are going to do, and then what are the basic topics like the definitions, examples, and theorems are to be covered. Definitely for this, these must be there. So that you must follow. So that protocol should be followed, and then other than that, what is that you are going to find something new that can also be included, and definitely application. So application for what the fuzzy set, if you are going to give your own, you're going to introduce that, then what is its application, and how it is relevant to the particular algebraic structure. It may have an application in your graphs too. So even that you can give. So regarding graphs, we have already algebraic graphs we have already defined, and there are fuzzy graphs, so fuzzy algebraic graphs. So in that way you can give an application. So this is the research framework that you must know before you start with research in fuzzy algebraic structures. Thank you.